Hi friends, today I am going to explain about static modifier in Java. Static modifier is applicable for variables, methods, blocks and nested classes. This modifier is not applicable for outer class. So we should not use static modifier for outer class. Let's see in VS Code, we'll create a main.java file and here main is a outer class and here we take a system.out.println statement main method. So this is a main class. Here for main class we should not use static modifier for outer class. Here main is a outer class. If we create another class, so here if we create class inner main, it is a inner class. So this inner main is a inner class and main is a outer class. So we should not use static with outer class. It says that illegal modifier for the class main. Here for outer class only applicable modifiers are public, abstract and final are permitted. It clearly says that public, abstract and final are permitted. So static we should not use for outer class. And we can use static for inner classes. Here if I use static here, it doesn't raise any error. We can clearly use static for inner classes. So we'll see about inner classes in our future videos. So here you should remember that static cannot be used with outer classes. And we'll see key idea. When you don't use static with a variable, it's called as instance variable. As we know that instance variable is a variable which have every object gets its own personal copy. So if a variable is instance, for every object a new copy is being created. Let's see here. Here if I take int x is equals to 10. Here it doesn't use any static keyword. So this x variable is an instance variable. So if I create objects, main m is equals to new main. Let's take m1 as object 1 and m1 dot x is equals to, let's assign for object m1 x value is 12 and let's create another object m2 and for m2 let's assign the value as 13, x as 13. So it is an instance variable. Instance variable for every object, a new instance variable is being created. A new instance variable, a new value is being assigned. So for m1 x value is 12 and for m2 x value is 13. So if I print the values, m1 dot x here the value of m1 and if I print m2 dot x, now m1 dot x prints the value as 12 and m2 dot x prints the value as 13. So if we compile and run the code, java main.java, it compiles fine. And if you run the code, the output is 12 and 13. Here, for every object, a new value is being assigned. For m1, x value is 12. For m2, x value is 13. It is with instance variables. And here, but when you do use static, when we use static keyword, only one copy exists at the class level and it's shared by all objects like a common pool. So whenever that variable is static, the only single copy is shared with all the objects. Let's see here, if this x is static, here I have taken the value of x as static. So here I have created m1 object and m2 objects. So for m1 and m2, only single copy is being shared here. So this is only for M1 and M2. So if M1 is modified the value of X, now X become 12. And whenever M2 is also modified the value of X, now X value become 13. So whenever a object is modified the static variable, it is changed for all the objects. Whenever I print the values for X for object M1 and M2, the final value of the static variable is here 13. So instead of 12 and 13, here the output is 13 and 13 because it is shared with all the objects. So if one object change the value of X, then the value is changed for every object. So if I save the code and if I compile and run the code, it compiles fine. And if I run the code, here the output should be 13 and 13. Let's see here 13 and 13 because static variable is common for all the objects. So if one object change the value of static variable, the value is changed for all the objects. If it doesn't assign the value here, now the value of X is 10. So let's see if we compile and run the code. For both the objects, the value is 10 only. If the second M2 dot X is equals to 13, here second object is modified as 13. So when the second object is modified at 13 and after that the first object is modified as 1000, here the last modified value is 1000. So whenever we print the value of M1 dot X and M2 dot X, the value is 1000 for both the cases because the single value is being shared with all the objects. So here the output is 1000 and 1000. Here we should observe that static variables are shared with all the objects. The single copy is shared with all the objects. Whenever a single object changes the value, it reflects to all the objects. This is how static works. And let's see some access rules. Static area can't access instance members directly. So here static area in the sense the area under the static. So it is a static method. See here you see main is a static method. So the area under the main method is static area. So here the rule is static area can't access instance members directly. So it is a static area. It can't access instance members directly. So without using the object, if you print system.out.println of X, it raises an error. It says that cannot make a static reference to the non-static field X. X is a non-static. So we can't use non-static members inside the static area. If it is a static, we can use. If it is static, we can use it. But if it is not static, we can't use directly inside the static area. That is a rule. So we can use, if we want to use X, we have to create the object. With the object only we can access the X, that is non-static. If we want to access the non-static members inside a static area, we have to create object. We can't directly access the non-static members inside the static area. It raises an error. And let's see the second point. Instance area can access both static and instance members. So instance area in the sense, let's create a method, instance method, public void m1. We are not keeping here static variable. So it is a instance method. Instance method can access static and instance variables directly. Here I take another variable y, that is a static variable, value as 11. So here x is a instance variable and y is a static variable. So inside the instance area, we can directly access both static and instance variables. Here I can directly access the x, that is which is instance, and I can directly access y, which is static. So under the instance area, we can access both instance methods, instance variables and static variables. But under the static area, we can only directly access static variables only. We can't directly access instance variables under the static area. But under the instance area, we can access static and instance variables directly. So it is a instance method. Instance method means we should not directly call the method. If I call directly here M1, it raises an error because it is an instance method. Instance method cannot access directly inside the static area. So we have to create an object, and with that object only we can access the instance methods or instance variables. So here using the object, I am calling M1 method, which is instance method. Inside the instance method, we can directly access instance variables and static variables. If I compile and run the code, it works fine. It prints 10 and 11. And let's say at that point, static members can be accessed from anywhere, that is static or instance area, like VIPs of the class. So static members here, static members in the sense y can be accessed anywhere directly. Here y is equals to 1. From the instance area, I'm accessing y directly, and from static area also I can access y directly. Here without the reference of object, we can directly access the y. It doesn't raise any error because it is static. It can be accessed anywhere directly. But if I want to access x here, it raises error because it is instance variable. It cannot access directly under the static area. So static variables can be accessed directly anywhere under the instance area or under the static area. So let's see one real-time example. That is, imagine you are creating a class called student class. Inside a student class, we may have roll number for the student and also college. Those are the two variables. First is roll number, second is college. So in a same college, all the students can share the college name as same, but the roll number is different. So for every student, roll number is different. So for every object, roll number is different. That's why we can take that thing as instance variable as roll number, and we can take college name as static because all the objects can share the single copy. That is, all the students can share this college name. So here I have taken college as static because all the students can take the same college inside a same college. Every student have the college name as same, but the rule numbers are different. So I have taken rule number as instance and college name as static. So here, whenever we are creating an object, we can assign roll number, and the college for all the students is ABC college, some random college. Because inside a same college, all the students have on the ID card, all the students have the same college name, but the roll numbers are different. So that college name can be shared, a single copy can be shared for all the students. That's why I have taken it as static, and for every object roll number is different. That's why I have taken it as instance. So you should remember that instance variables are different for every Our instance variables uh, creates a new for every object. That is, every object has a new instance, but a single copy is being shared for every object that is static. So if we take something as static, that thing is being shared with all the objects. That is a shared thing. There is no duplication, only one thing is being shared. But instance is for every object, a new instance variable is being created. So here the memory wastage is there, but here the single variable is being shared by all the objects. This is how static and instance works in Java. Thank you. Please like, share and subscribe for more videos.